This is a lesson for Chapter 4, Section 4 and Chapter 4, Section 5. A little review on both, and so let's take a look at the first one. 4.4 is dealing in graphing using slope-intercept form. And so that's what we're going to do in these first two problems. So on this one, it's in the slope-intercept form where y is by itself. So again, that slope-intercept form goes this way. Y equals mx plus b. And so when y is by itself, it's isolated, we've got our slope for the coefficient in front of x, and b represents our y-intercept, where it crosses the y-axis. We're going to use that point first. So let's go ahead and name off our y-intercept, which we use the variable b to represent. So that's -5. So again, that point is 0, -5. Because I substitute 0 in for x, it cancels the term out. Y is -5. So we go down 5 spaces on the graph, put a dot right there, and then use the slope. The slope of this line is 4, and we're going to represent 4 as a fraction, as 4/1, and that tells me to go up 4 spaces and right 1 space. And so I'll do that a few times. Up 4 spaces, right 1 gets me on that line, and then up 4 spaces, 1, 2, 3, 4, and over 1 gets me on that line, and so I go ahead and draw the line between those points. So the next one, I have a y-intercept of -2. It's what I get when I cancel out the x term. So that ordered pair is 0, -2. So over 0 and down 2 spaces puts me on that line, and then I use the slope. The slope is -4 to 5. So this time, since it's a negative slope, only one term is negative. So I'm going to end up going down 4 and then right 5. That's one way I could do it. However, I'm kind of running out of space going down 4. I could kind of show where it is because it's only one lower than where my graph is, and then right 5 would put me over in this spot right here. So I can also go another direction. That's the same thing as going up 4, but then left 5. So up 4, left 5 would get me on that same exact line. So if I do that, I go up 1, 2, 3, 4, and then left 5. 1, 2, 3, 4, 5 puts me right there. You can see how those points line up and make that line. So that is slope-intercept form. Let's take a look at the other form that we'll see. And this is graphing using intercepts. And so we use this method when x and y are on the same side. So it's in what we call standard form, where we have ax plus by equals c. So we've got the constant by itself, the 60 by itself, and we've got the x and the y term on the other side. So we're going to use the intercept method. I'm going to find the x-intercept. And I do that by setting y equal to 0. So I'm going to cancel out this term, and I'm just left with 15x equals 60. So I divide by 15, and I get my answer. So x equals 4 in this case. And so this point represents 4, 0. It's where the line crosses the x-axis. So I'm going to put a dot right there where it does. It's 4 spaces over. And then I find the y-intercept. And so the y-intercept is when I set x equal to 0. So I cancel out the x term. I'm left just with the y term. Make sure you bring that minus sign in front of the 12 down, though. Divide by -12, and that gives me y equals -5. So that point is 0, -5. So I'll go down 5 spaces, put a dot right there, and then draw the line between those points. So looking at the next problem, it looks just a little bit different because I have the constant being negative this time. So I do it the same way. X-intercept, I set y equal to 0. So I cancel out that 8y because 0 goes in for 8, and I'm left with 10x equals -40. So when I divide by 10, I end up getting the answer of x equals -4. So it's going down 4 spaces to the left, and the point goes right there. Again, that is going to end up being the point of -4, 0. So the next point is the y-intercept, and I'm going to set x equal to 0 to find that. So when I cancel out the x term, I'm left with 8y equals -40. So when I divide by 8, I get my answer of y equals -5. So that point is 0, -5. So I go down 5 spaces on the y-axis, put a dot right there, and then draw the line between those points. So that is graphing using intercepts. Let's take a look at a word problem. So here it says you sold $16 worth of cheese, and it says write and graph an equation to to represent the amount of cheese you sold. Well, so it says we sold $16 worth, but we sold some different types. So let's take a look at the different types we sold. We've got Swiss over here at $4 a pound and cheddar at $2 a pound. So let's go ahead and use some variables to represent each. So we're going to say maybe like y equals the amount, the pounds of Swiss sold. And then we'll say maybe x equals the pounds of cheddar sold. So I know those it's pounds because if I look at it, it's $4 per pound. So because it's per pound, when I multiply the number of pounds by $4 per pound, that's going to give me a dollar amount, which is what it should equal at the end. It should equal $16. So I'm going to go ahead and write my equation. It goes x, and I'm going to write 2x because I have cheddar here. So 2x plus, and then 4y. Where did I get those? Well, right here. Cheddar is $2 per pound. So 2 times the number of pounds of cheddar. And then the 4, well, that came from right here. 4 is the cost of a pound of Swiss, $4. So $4 times by the pounds of Swiss sold is going to equal 16. So now we've written the equation. Now we're going to go ahead and graph it. So let's go and get a piece of graph paper. So in order to graph this, I want to write down what label my axes. And I said the y-axis was the pounds of Swiss sold. And I used my x-axis as the pounds of cheddar sold. And so it doesn't matter whether I used the x-axis for cheddar or the y-axis for cheddar. Neither of them is a dependent variable on the other. So it was arbitrary in this case. And you could have gone the other way, and your line would have just looked a little different. It would have been sloped at a different amount. And so we'll just stick with what we've got, and we're going to find out what kind of units to use in just a moment. But before I do that, I want to solve for x and I want to solve for y. I want to find out what the intercepts are. So I'm going to find the x-intercept. And remember, I set y equal to 0, and so that's going to leave me with the 2x equals 16, so x is 8. And so that represents 8 pounds of cheddar. Sold if we didn't sell any Swiss. And so that's actually one of the questions there. It asks us to define what the x-intercept is. So remember that x-intercept was 8, 0. 8 represents the x value, which is right up here, pounds of cheddar sold. 0 represents the y value, pounds of Swiss sold. So we're going to go by ones here. I'm going to label every other one. And I've got 2, 4, 6, and that's 8 and 10. So I'll put a dot right there at 8. And then let's find the y-intercept. The y-intercept is going to be when I set x equal to 0. So I go ahead and solve. I got 4y equals 16. So y is going to end up equaling 4. So I'm going to go up by 2's again. Well, go up by 1's, but I'll write every other number. And then I'll go ahead and put a dot where the 4 is on the y-axis. And what does that represent? Well, that is 4 pounds of Swiss sold if we don't sell any cheddar. And again, it's that way because if you look at the ordered pair, the ordered pair is 0 for x, and x is the pounds of cheddar. So we sold no cheddar, and we'd end up selling 4 pounds of Swiss because we sold $16 worth. And so the points along this line that I draw are possible solutions for our answer. And so any number, we could go ahead and take a point from the line and then carry it out to the y-axis, carry it out to the x-axis, and that would tell us the number of pounds of each that we ended up selling. So those are the types of problems that we're going to end up seeing on the homework. Good luck.